Commercial Chinese company Landspace performs static fire test on reusable Zhuque-3 rocket. Date: June 20, 2025. Location: Dongfeng Commercial Space Innovation Test Zone near Jiuquan Satellite Launch Center, China. Overview of the event. On June 20, 2025, Landspace, a pioneering Chinese commercial rocket startup, achieved a significant milestone in its journey towards space exploration by conducting a successful static fire test of its Zhuque-3 rocket. This critical test took place at the Dongfeng Commercial Space Innovation Test Zone, strategically located near the Jiuquan Satellite Launch Center in northwest China. The static fire test involved the ignition of 9 Tianke-12 methane-liquid oxygen engines, collectively generating a robust thrust of 7,542 kilonewtons kN for a duration of 45 seconds. Considered a pivotal step towards the Zhuque-3's inaugural orbital launch. This event demonstrates Landspace's commitment to advancing reusable rocket technology in China. Key highlights of the static fire test. 1. Test details. The static fire test conducted by Landspace marked a landmark achievement, as it was the largest and most automated 9-engine parallel cluster hot fire test in China's aerospace history. The engines ignited in a sequential manner, simulating real flight conditions closely and ensuring that all major subsystems, including engines, avionics, and pressurization systems, were compatible and functioning as intended. Comprehensive pre-launch preparations were undertaken, including propellant loading and tank pressurization, which confirmed the readiness of the rocket for its upcoming flight. 2. Zhuque-3 specifications. The Zhuque-3 rocket stands at approximately 66 meters tall and weighs around 570 metric tons. Designed with reusability in mind, the rocket aims for a minimum of 20 flights, promising to reduce launch costs by an impressive 80 to 90% compared to traditional single-use rockets. The rocket's first orbital launch is tentatively planned for the third quarter of 2025, during which it will carry a prototype of the reusable Haolong cargo spacecraft. 3. Competitive landscape. Landspace development of the Zhuque-3 aligns with the aspirations of various other Chinese companies in the private space sector, such as Space Pioneer and CAS Space, all of which are making strides towards launching reusable rockets to challenge established players like SpaceX. While Landspace's early attempts faced challenges such as the failure of its solid-fueled Zhuque-1 in October 2018, the successful launch of Zhuque-2 in July 2023, which reached orbit using methane-liquid oxygen propellant, showcased the company's resilience and innovation. 4. Future prospects. The success of the static fire test sets the stage for Landspace's future endeavors, including plans to initiate recovery attempts in 2026. This advancement signifies a critical leap in China's reusable launch vehicle technology. The company has secured substantial financial backing, notably a $123 million investment from the National Manufacturing Transformation and Upgrading Fund in December 2024, enhancing its capabilities to pursue ambitious rocket programs. Comparative insights from various sources. Multiple sources have reported on the static fire test, each highlighting different aspects of the event. Source 1: Space News focused on the technical execution of the static fire test and provided insights into the operational preparations that led to the ignition. It emphasized the significance of this test in validating the rocket systems and noted that the Zhuque-3 is slightly shorter than previously reported, potentially affecting early launch payload capacities. Source 2: Interesting Engineering highlighted the competitive context of Landspace efforts, drawing parallels with SpaceX's achievements in reusable rocket technology. The article detailed the static fire test procedures and the engine's performance, reinforcing the importance of this milestone for Landspace's future launches. Source 3: Xinhua offered an official perspective on the test, underlining its importance in China's broader goals for reusable rocket technology. This source elaborated on the test's successful replication of flight conditions and the implications for the Zhuque-3's operational capabilities. Conclusion. Landspace's successful static fire test of the Zhuque-3 rocket represents a significant leap forward in China's pursuit of advanced reusable rocket technology. As the company gears up for its inaugural flight scheduled for later in 2025, the successful validation of its systems during the static fire test lays a solid foundation for future endeavors in the commercial space sector. With substantial financial support and a competitive landscape, Landspace is poised to play a vital role in shaping the future of space exploration and launch capabilities in China. The recent successful static fire test of Landspace's reusable Zhuque-3 rocket marks a significant milestone in China's commercial space endeavors. A few counterintuitive pieces of information emerge from the details of this event and the broader context of the Chinese space industry. 1. Comparison with established players. While many might assume that the Chinese space sector is primarily government-driven, the emergence of Landspace and other private companies shows a shift towards a competitive landscape. The fact that a commercial startup is challenging established giants like SpaceX is unexpected, considering that China has generally been perceived as having a more centralized space program. 2. Failure and success dynamics. Landspace's history includes a notable failure with its Jiuquan launch in 2018, which many might view as a setback. However, this failure appears to have catalyzed a shift in focus towards the more innovative Zhuque-2, which successfully reached orbit in July 2023. This illustrates a counterintuitive lesson in risk-taking and pivoting in the face of challenges. Sometimes failures can lead to better outcomes. 3. Cost efficiency through reusability. The Zhuque-3 is designed to reduce launch costs by 80 to 90% compared to traditional single-use rockets. This claim may seem surprising, especially given the high initial development costs associated with reusable technology. The notion that reusability can lead to such dramatic cost reductions challenges traditional perceptions of launch economics that prioritize the immediate costs of development over long-term operational savings. For the technical complexity and automation, the static fire test was described as the largest and most automated 9-engine parallel cluster hot fire test in China to date. This level of automation may contradict the common image of space launches being labor-intensive and requiring extensive manual oversight. The fact that Landspace is pioneering automation in this context demonstrates a progressive approach that contrasts with older methodologies still utilized by some established players. 5. Design choices reflecting future needs. The Zhuque-3's design allows for its first stage to be checked without detaching it from the rocket after recovery, a feature resembling aircraft maintenance routines. This innovative design choice is counter to conventional practices in rocketry, where stages are typically discarded after a single use. The ability to perform checks and reuse components like an aircraft could reshape expectations around maintenance and operational readiness in spaceflight. 6. Market dynamics and global competition. While many view SpaceX as the primary competitor in the reusable rocket domain, the rise of multiple Chinese companies, including Landspace, Space Pioneer, and CAS Space, suggests a more nuanced competitive landscape. This development challenges the assumption that the race for reusable technology is a contest solely between Western companies, highlighting the growing capabilities and ambitions of the Chinese private sector. 7. Public and private sector synergy. The funding Landspace received from the National Manufacturing Transformation and Upgrading Fund is an example of a public-private partnership that is often overlooked in discussions about space innovation. This collaboration contradicts the narrative that private companies must solely rely on private capital to innovate and succeed. Instead, it highlights how government support can foster technological advancements in the private sector. 8. Future recovery attempts. The announcement of recovery attempts starting in 2026 might seem premature given that the Zhuque-3 has yet to complete its inaugural flight. This forward-looking perspective could be seen as either overly ambitious or indicative of a robust confidence in their technology, which could counter the typical caution exercised in aerospace timelines. In conclusion, While the Zhuque-3 static fire test is a step toward enhancing China's capabilities in reusable rocketry, the surrounding context offers several counterintuitive insights about the dynamics of competition, the relationship between failure and success cost structures in spaceflight, and the evolving nature of public-private partnerships in the space sector. The report on Landspace static fire test of the Zhuque-3 rocket contains several crucial aspects that are significant yet may be overlooked by the general audience. Here are key points that merit deeper exploration. 1. Scale of the test. The Zhuque-3 static fire test is described as the largest and most automated 9-engine parallel cluster hot fire test in China to date. This is significant because it demonstrates not only the technical capability of Landspace but also represents a milestone in China's space industry. The success of such a large-scale test indicates a maturation of technology that could rival established players like SpaceX. The sheer number of engines and the automation involved suggest a high level of engineering sophistication and could pave the way for future large-scale rocket designs both in China and globally. 2. Engine technology. The use of the Tianke-12 and methane-liquid oxygen engines is noteworthy. Methane as a fuel is gaining traction in the space industry because it can be produced from Martian resources, making it a potential candidate for long-duration space missions. The significance of this choice extends beyond immediate launch capabilities. It hints at future considerations for interplanetary travel. This aspect may not be immediately apparent in reports that focus solely on the static test's success. 3. Reusability and cost reduction. The Zhuque-3 rocket is designed to be reusable with expectations for at least 20 flights. This feature is critical as it promises to reduce launch costs by 80 to 90%. The implications of this cost reduction are vast. It can democratize access to space, making it more feasible for smaller satellites and commercial enterprises to launch payloads. The potential for lower costs could significantly alter the competitive landscape in satellite deployment and other space activities. Understanding this aspect requires a grasp of the economic implications of reusable technology, which are often glossed over in technical discussions. 4. Launch sequence simulation. The test closely replicated actual flight conditions, which is significant for validating the rocket's design and systems integration. This level of fidelity in simulations is crucial for risk reduction in future launches. The ability to execute a full sequence, from propellant loading to ignition, indicates robust engineering practices and the potential for reliability in subsequent launches. Many reports may miss the importance of this simulation aspect, which is vital for ensuring mission success. 5. Competitive landscape. The competitive context of the Chinese commercial space sector is crucial to understanding the significance of Landspace achievements. Companies like Space Pioneer and CAS Space are also emerging with their own reusable technologies. This competition is likely to accelerate innovation and could lead to a rapid evolution of capabilities within China's space industry. The implications of this competition extend beyond national pride. They reflect a global race in space technology that could influence international collaborations and geopolitical dynamics. 6. Funding and support. The report mentions that Landspace has secured substantial funding, including $123 million from the National Manufacturing Transformation and Upgrading Fund. This financial backing is significant as it underscores governmental support for private space endeavors in China. Such funding is not just a lifeline for development but also a signal of the state's commitment to advancing its space capabilities. The relationship between government funding and private innovation in space exploration is often under-discussed but is crucial for understanding the broader ecosystem. 7. Historical context. Landspace's journey from the failure of Zhuque-1 to the success of Zhuque-2 and now the static fire test of Zhuque-3 demonstrates resilience and iterative development in rocket technology. This historical context is significant as it reflects the learning curve and the evolution of engineering practices in a relatively short time. Recognizing this trajectory can provide insights into the potential for future successes and the rapid pace of technological advancement in the space sector. 8. Future recovery plans. The mention of recovery attempts starting in 2026 is significant because it indicates Landspace's long-term vision for reusability in rocketry. The ability to recover and refly rocket stages is a key aspect of reducing costs and increasing launch frequency. Many may overlook this forward-looking statement, but it represents a crucial step toward achieving the operational capabilities seen in more established companies like SpaceX. In summary, while many reports may highlight the successful static fire test and the technical specifications of the Zhuque-3, the broader implications of this development, such as advancements in engine technology, cost reduction strategies, competitive dynamics, funding importance, and the learning curve in aerospace technology, are critical to understanding its significance in the global context of space exploration. These factors could redefine not only China's position in the space race but also the future of space access and utilization globally. The static fire test of the Zhuque-3 rocket by Landspace represents a significant development in China's commercial space sector. Here are 4 key points for in-depth analysis and discussion. 1. Technical significance of the static fire test. The static fire test is a pivotal moment in validating the Zhuque-3 rocket's design and engineering. The test marked the largest and most automated 9-engine parallel cluster hot fire test conducted in China. It involved the ignition of 9 Tianke-12A engines simulating actual flight conditions over a sustained 45 seconds and generating 7,542 knots of thrust. This test confirmed the operational readiness of critical subsystems such as engines, avionics, and ground systems. The success of this test not only demonstrates Landspace's technical capabilities but also sets a precedent for future tests and launches in the Chinese space industry, emphasizing the importance of rigorous ground testing in the development of complex aerospace systems. 2. Economic implications of reusability. The Zhuque-3 is designed to be a reusable rocket aiming to drastically reduce launch costs by 80 to 90% compared to traditional expendable rockets. This economic model aligns with global trends in the space industry, particularly following SpaceX's pioneering efforts in reusable launch vehicles. By achieving reusability, Landspace could position itself competitively in the market, attracting commercial payloads for satellite launches and other missions. The potential for the Zhuque-3 to fly at least 20 times enhances its economic viability and could lead to a more sustainable model for space exploration and utilization. 3. Competitive landscape in China's private space sector. Landspace's advancements with the Zhuque-3 come amid a growing competitive landscape in China's private space sector. Companies like Space Pioneer and CAS Space are also developing their own reusable rockets. This competitive environment fosters innovation and could accelerate the pace of technological advancements in the industry. However, it also presents challenges for individual companies to distinguish themselves and secure funding and partnerships. Analyzing the strategies adopted by these companies, including their funding sources and technological innovations, can provide insights into the future trajectory of China's private space initiatives. 4. Future prospects and challenges. Looking ahead, Landspace plans to conduct its first orbital launch of the Zhuque-3 in the third quarter of 2025, which will carry a prototype of the reusable Haolong cargo spacecraft. The transition from static fire testing to successful orbital launch will be critical as it involves a series of complex challenges, including achieving safe recovery and demonstrating the ability to reuse the first stage. The funding received from the National Manufacturing Transformation and Upgrading Fund indicates strong governmental support, which is crucial for navigating these challenges. However, the path to successful recovery and reusability remains fraught with technical and operational hurdles that will need to be addressed to realize the full potential of the Zhuque-3. In summary, the static fire test of the Zhuque-3 rocket encapsulates the intersection of technological innovation, economic strategy, competitive dynamics, and future challenges in the evolving landscape of the Chinese commercial space sector. 1. NASA's Space Shuttle Program 1981 to 2011. The Space Shuttle program was one of the most ambitious and complex space programs in history, aiming to develop a reusable spacecraft that could transport astronauts and cargo to and from low Earth orbit. The program successfully launched 135 missions, and the reusable nature of the shuttles dramatically changed the economics of space travel. However, it faced significant challenges, including the Challenger disaster in 1986 and the Columbia disaster in 2003, which raised questions about safety and reliability in reusable spacecraft. 2. SpaceX Falcon 9 reusable rockets 2010-present. SpaceX revolutionized the commercial space industry with the development of its Falcon 9 rocket designed to be reusable. The first successful recovery of a Falcon 9 first stage occurred in December 2015, marking a significant milestone in reducing launch costs. SpaceX's iterative approach to rocket design, which includes numerous static fire tests and successful reflights, has led to the frequent reuse of rocket components, setting a new standard for the aerospace industry and enabling a new era of cost-effective access to space. 3. Blue Origin's New Shepard 2015-present. Blue Origin, founded by Jeff Bezos, has focused on developing reusable rocket technology with its suborbital New Shepard vehicle. The vehicle is designed for space tourism and research missions, successfully completing multiple flights with significant milestones, including booster landings and capsule recoveries. The static fire tests conducted by Blue Origin play a crucial role in ensuring the reliability and safety of the system, similar to the approach taken by Landspace with its Zhuque-3 rocket. The New Shepard program aims to demonstrate the feasibility of reusability in space travel, contributing to the growing commercial space sector. The successful static fire test of the Zhuque-3 rocket by Landspace marks a significant milestone in China's pursuit of advanced space technology and reusable rocket systems. As we look ahead, several predictions can be made regarding the future of Landspace, the Zhuque-3, in the broader context of the commercial space industry in China and globally. 1. Inaugural flight and operational milestones. The first orbital launch of the Zhuque-3 is tentatively scheduled for the third quarter of 2025, carrying a prototype of the Haolong reusable cargo spacecraft. This launch is critical as it will serve as a benchmark for Landspace operational capabilities. If successful, it will position Landspace as a serious competitor in the global space launch market, particularly against established players like SpaceX, which has demonstrated the viability and economic advantages of reusable launch systems. 2. Advancements in reusable technology. Following the static fire test, Landspace aims to initiate recovery attempts starting in 2026. The success of these recovery operations is crucial for justifying the high costs associated with rocket development and launch. If recoveries are achieved effectively, this could lead to rapid iterations and improvements in rocket design, ultimately enhancing the Zhuque-3's payload capacity and operational frequency. The anticipated cost reductions of 80 to 90% in launch expenses could revolutionize the commercial launch market, making space more accessible for smaller companies and increased satellite deployment. 3. Competitive landscape in the Chinese space sector. The success of Zhuque-3 will likely catalyze further investment and innovation among other Chinese private space companies such as Space Pioneer and CAS Space, which are also working on their own reusable rocket technologies. This burgeoning competition could accelerate technological advancements across the sector, leading to a robust ecosystem that supports various applications including satellite deployment, space tourism, and potentially interplanetary missions. 4. International collaboration and market expansion. As China's commercial space capabilities grow, we can expect an increase in international collaborations. Chinese companies including Landspace may seek partnerships with foreign entities to expand their technological expertise and access international markets. This could include joint ventures for satellite launches, research collaborations, or even participation in larger international missions, enhancing China's presence in the global space community. 5. Regulatory and policy evolution. The rapid development of the commercial space sector will likely prompt regulatory bodies in China and globally to adapt existing frameworks to better accommodate new technologies. This could involve streamlining the approval processes for launches, establishing safety protocols for reusable vehicles, and addressing the environmental impacts of increased launch frequency. As Landspace and others demonstrate operational success, policymakers will need to ensure that regulations support innovation while safeguarding public interests. 6. Technological innovations in propulsion and materials. Landspace's use of methane-liquid oxygen engines represents a shift towards more sustainable rocket propellants, aligning with global trends toward environmentally friendly technologies. As the industry matures, we may see further innovations in propulsion systems, materials science, e.g., lightweight composites, and engineering practices that enhance the performance and safety of rockets. These advancements may also lead to new designs and concepts for future space missions, including deep space exploration. 7. Implications for global space economy. The emergence of competitive Chinese launch providers is likely to exert downward pressure on launch costs globally. As more players enter the market, both established companies and startups will need to innovate and differentiate their services, potentially leading to a wider range of launch options and pricing structures. This increased competition could stimulate demand for satellite launches, especially for small satellites and CubeSats, as businesses and governments look to leverage space-based technologies for various applications, including communications, Earth observation, and scientific research. Conclusion. The successful static fire test of the Zhuque-3 rocket represents a pivotal moment for Landspace and the Chinese commercial space sector. Looking ahead, the expected advancements in reusable rocket technology, coupled with the competitive landscape and potential regulatory changes, will likely reshape both the domestic and global space industries. As China continues to invest in its space capabilities, the implications for international collaboration, market dynamics, and technological innovation will be profound, positioning China as a key player in the future of space exploration and commercialization.